So we are looking at Lesson 8.7's homework in the textbook on page 502. And we're looking at multiplying and dividing square roots. And even more importantly, we're going to be looking at simplifying square roots. That's going to be the most important part of today. All right, so jumping in, we're going right into number 1 here. We have got the square root of 8 times the square root of 2. Get used to hearing those things called radicals. So you could read this the square root of 8. You could also read this as radical 8. Radical 8 times radical 2. Okay, so when we simplify, that's how we're going to read them with the word radical. So square root of 8 times the square root of 2. If we went ahead and tried to simplify those first, and we took the square root of 8, it's a nasty number. You'd have to write that whole thing down. Square root of 2, whole thing down. You'd be multiplying those two things together. So if I went up, if I click that and I hit times, and then I click that and I hit times and I hit equals, it's going to give me this decimal. Now, these numbers were actually rounded because they ran out of space. And so this number is not going to be exact because we threw these off a little bit by cutting them off and not going on forever. And so you can see 3.9999999 is really close to 4 because the answer is actually 4. If I take the square root of 8 times the square root of 2, you can see the answer is 4. So how? So what I can do is I can go ahead and just multiply these out because there is no nice square root of 8. It's a nasty decimal. There's no nice square root of 2. It's a nasty decimal. But these together, 8 times 2, is the same thing as the square root of 16. And that we know has a nice answer of 4. The square root of 16 is 4 because 4 times 4 is 16. So our answer here is 4. So we can go from some nasty decimals to a nice answer by just combining these through multiplication and then taking the square root later rather than doing the square root here first. So number 2, we're going to kind of go the opposite direction. 36 times 81 times 100. So the long way to do this would be to simplify in here first. So let's do it that way, and I can show you an easier way after. So 36 times 81 times 100. We get this long number. So I get 291,600. 291,600. If we now take the square root of that number, we get 540. So that's one way to do it. But what we need to recognize is that 36, 81, and 100. Okay, those are perfect squares. They have nice whole number square roots. So 36, square root of 36 is 6, right? 6 times 6 is 36. Square root of 81 is 9. Square root of 100 is 10. And if I went ahead and I just multiplied these, 6 times 9 times 10, I will also get 540. So I need you to see that you could multiply all of these and then take the square root. Or you can actually take the square root of each one individually, because what you're actually doing when you do that is rewriting this, kind of like we did up here, as square root of 36 times square root of 81 times the square root of 100. You can split it up into pieces. And now it's just 6 times 9 times 10. Just like up here, we had square root of 8 times the square root of 2. Well, that's the same thing as the square root of 8 times 2, all of it underneath, which is 16. And then we go there. So there's all different, variations on this. So we just need to know that we can simplify inside and then square root, or we could actually take the square roots, since these have nice ones, and multiply later. All right, number 3, looking at division. Square root of 40 divided by square root of 10. Neither one of those have nice square roots, right? Square root of 40, nasty. Square root of 10, nasty. But I can do this very quickly in my head without a calculator, because I know 40 divided by 10 is 4. So the square root of 40 divided by the square root of 10 is the square root of 4. And the square root of 4 I already know is 2. Because when I, again, think of square roots, it's asking me what number times itself gives me 4. 2 times 2 gives me 4. So the square root of 4 is 2. So I can simplify this and do all of this without a calculator. So let's try this next one. I've got square root of 6 to the third power divided by square root of 6. Okay, so we can rewrite this as the square root of 6 times 6 times 6 over the square root of 6. And I can even split this up into separate square roots if I wanted to. Don't have to. And then I already know from our last couple units that these are going to cancel themselves out here. And so I'm left with the square root of 6 times the square root of 6, which we've talked about that property. If you multiply any square root times itself, you're just going to get the number on the inside. So my final answer here is going to be 6. And if we've forgotten that, it's because if you think back to number 1, we're multiplying these together. So I'm going to get the square root of 36, 6 times 6, and the square root of 36 is 6, because 6 times 6 is 36. All right. Number 7 now. Which one of these is not equal to square root of 50? 3 of these are equal to the square root of 50. So if I look at letter A, square root of 5 times the square root of 10, you multiply those together like we just did a couple times, you're going to get square root of 50. So that one's good. Addition. Okay, addition doesn't quite work like that. Now if you look at these, square root of 25 is 5, because 5 times 5 is 25. So what this is actually saying is 5 plus 5. So the answer to letter B, the simplified version, is 10. This is 5, this is 5, 5 plus 5 is 10. So think about, is the square root of 50 10? We should know right off the bat, no, it's not. Not because we know what the square root of 50 is, but we know that 10 times 10 is not 50, it's 100. So the square root of 50 is not 10. So B is going to be the answer here. That is the one that is incorrect, but let's take a look at the other ones and make sure we understand why these are correct. So square root of 2 times square root of 25 is square root of 50, right? 2 times 25. What about letter D? We have 5 radical 2, or 5 times the square root of 2. How does that equal this? And what we actually can do is look up at letter C real quick. If we had the square root of 2 times the square root of 25, there's some simplifying we could do because the square root of 25 is 5. That has a nice whole number perfect square. So square root of 2, can't do anything with it, but square root of 25 is 5. And if you look at this combination, that's what this is, 5 times the square root of 2, just the order flipped there. Okay, so that is actually equivalent to this. Square root of 50 simplifies down to 5 radical 2, and we're going to come back to that in just a minute. So out of these 3, the one that is not equivalent is letter B, square root of 25 plus square root of 25. All right, number 9. Now here's the part I really want to focus on. Simplifying these square roots. You're going to see this as you move forward in your math classes, so it's important to be able to do this. Square root of 18. Can we simplify this? And so 18 itself doesn't have a nice square root, so it doesn't just turn into a whole number. So what we're looking to do is to split this into pieces, and one of these 2 pieces has to produce a nice whole number square root. And so we need to think of all our numbers here that when we square them, give us something, or when we square root, gives us something that's a whole number. So we're looking at numbers like 4 and 9 and 16. So think about, why are these numbers special? What am I talking about? I know the square root of 4, I know the square root of 9, I know the square root of 16. It's because 2 squared is 4, and 3 squared is 9, 4 squared is 16, 5 squared would be 25. So I can take the square root of 4, it's 2. I can take the square root of 9, it's 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6, because 6 squared equals that. So I'm looking for one of these special numbers so that I can split this up. Now, yes, 1 squared is 1, so the square root of 1 is 1. right? But when we're splitting this up, that's not going to help us simplify this. We'd split it up with a 18 and a 1. The square root of 1 would become a 1, and we're still left with the square root of 18. So we're not going to worry about that one because it doesn't help us simplify. But all these other ones, and eventually you're going to have to continue even further with some big numbers. Okay, but right now we're just worried about these. So I'm going to take a look at these, 4, 9, 16, 25, 36 perfect squares. Do any of them go into 18? 4 does not, but 9 does. So what I can do is split this square root of 18 into two pieces. And you're basically factoring what numbers multiply to make 18. 9 and 2. So the square root of 9 times the square root of 2 is the square root of 18. So I'm working backwards. I'm splitting the square root of 18 into two pieces. Now I specifically chose these two pieces because you might have said, well, what about 6 and 3? That's equivalent, but that doesn't help us simplify because I can't turn square root of 6 into anything. I can't turn square root of 3 into anything. So yeah, we split it up, but we haven't done anything to help ourselves. Down here we have, because the square root of 9 is a nice number. It's 3. So the square root of 9 becomes 3. Square root of 2 we cannot do anything with, so it's going to stay here. Technically they're being multiplied, but you don't have to write that. You just attach them like you would like a 3x. Okay, it's 3 radical 2. And this is our final simplified answer from the square root of 18. So what we're doing is we're looking to split our number into pieces, and one of those pieces needs to be one of these perfect squares so we can simplify it further. All right, so we're going to number 10 now. Square root of 24. So first you want to think about numbers that multiply into 24. We've got 2 times 12. Neither one of those fits this. Okay, 8 times 3. Neither one of those. Can't take the square root of 8 or the square root of 3 and get a nice whole number. But I can do 6 and 4, where 4 is one of those magic numbers. So the square root of 6 times the square root of 4 is 24. Square root of 24. The reason I picked these out of these is because 4 has a nice whole number square root. It's 2. So I can't do anything with the 6, but I've now created the 2. The whole number we're going to use as a coefficient. It's going to go up front. Treat the radical or the square root like an x. It goes at the end. So you're not going to write square root of 6 times 2. You're going to put the 2 in front. Final answer is 2 radical 6. All right, 11 square root of 50. We kind of already dabbled in this up here, but let's show the work. I need to split 50 into two pieces. So you might think 10 times 5. That's true, but neither one of these have a nice whole number square root. So what else? Does 4 go into 50? No. Does 9? No. 16? No. 25? Yeah. 25 times 2 gives me 50, and 25 has a nice whole number square root. So if I split the square root of 50 into square root of 25 times the square root of 2, this simplifies to 5. Square root of 2 just drops down. Final answer, simplified version of square root of 50 is 5 radical 2. This is called simplest radical form. So we're going to start to use that word radical a lot. So it just says simplify the square root, but if it says simplest radical form, this is what we're looking for. Okay, now we're going to come over here to 16 through 19. And we've already done Pythagorean Theorem. We did in yesterday's work. But when we got to the end, we just took the square root and we rounded it. Right? We did it in the calculator and we got an approximate answer. Instead of getting an approximate answer, which we talked about when we round things, those answers aren't great because they're not actually the real number. We've rounded it. They're a little bit off. If we can just simplify like we simplify a fraction, we'll have an exact answer. Okay, so it's better to put it in simplified form or simplest radical form as opposed to rounding a decimal, which is an inexact number. So we want to ideally have an exact answer. And so sometimes the directions will say give an exact answer, or they'll say give a simplified form, simplest radical form, something along those lines. Okay, rounding is not exact. Simplifying will give you an exact answer. So let's jump in here on 16. I'm going to draw the picture real quick. And so we talked about Pythagorean Theorem is only good for right triangles. Right triangles are made up of two legs, which come out from the 90. That's always your A and your B. So 8 and 6 are my A and my B. And most importantly is my C, called my hypotenuse, whatever is across from the 90. That has to go in for C. So you always kind of want to start there. So C becomes Y, A and B become 8 and 6, and it doesn't matter which one you put where. So I have 8 squared plus 6 squared. So this is 64 plus 36 equals y squared. I can go ahead and simplify that to 100, put those together. And so y is not 100. Y squared is 100. So whatever y is, if I square it, I get 100. Now we should know that one right off the bat. That's 10. 10 squared is 100. Now mathematically we need to show it. What are we actually doing? We are taking the square root of both sides. So the square root of y squared is y, because y times y is y squared. And the square root of 100 is 10, because 10 times 10 is 100. And so we have gotten a nice, perfect answer. No simplifying needed. 17. As I plug into the Pythagorean theorem, a squared plus b squared equals c squared, I look for my c and put it in the right spot. So 6 goes here. My legs go in for a and b in any order I want. And I'm going to go ahead and expand these. So x squared I can't do anything with. 3 squared is 9. 6 squared is 36. We don't start taking the square root until we've isolated that variable. So we're going to go ahead and minus 9 from both sides. And we're going to get 27. And so whatever x is, when I square it, I get 27. So some number times itself is 27. So clearly that's not one of our perfect squares. This would be a decimal answer if we plug it in our calculator. So if the directions said round your answer to the nearest whatever, you would plug it in the calculator and round it. But our directions say, well, they actually do say then approximate to the nearest hundredth. So we are going to go ahead and do this after we simplify. So let's go ahead, since we already have this, and write this down. Nearest hundredth, tenths, hundredths, tenths, hundredths. So the 1 is going to stay. The 9 gets rounded, either stays the same or goes up. The 6 bumps it up. So think of it like a 19 getting bumped up by the 6. So this is going to be 20, which you could also just put as 5.2. So that's the approximate answer, is 5.2. But now let's talk about the exact answer simplified. We're going to take the square root of both sides. So that gives us the x. This is what we're trying to do. So we square root x squared to get x. Square root of 27, again, not a nice number, but we can simplify it. So we're thinking about those numbers, 4, 9, 16, 25. Numbers that have nice square roots, 2, 3, 4, and 5. So when I look at 27, can I split it into pieces based on one of these? And the 9 is the number I'm looking for. So I'm going to split the square root of 27 into the square root of 9 times the square root of 3, because 9 times 3 is 27. And now I can simplify the square root of 9 to 3. And square root of 3 can't go anywhere. And so it's going to look like this. Now just to show you some equivalence here, I'm going to do 3 times the square root of 3. And notice that you get the same answer. So 3 times the square root of 3 is the same thing as the square root of 27. They are equivalent. All right, 18. Plugging into Pythagorean Theorem. Most important part is to get your C correct. So 11 is my C. A and B go wherever. To solve this, I'm going to expand. So 49. This is 121. I want to isolate my x squared before I take a square root here. So I'm going to go ahead and minus 49. leaving me x squared equals 72. And the square root of 72 is not a nice number. There's no number times itself that gets me 72. So what I want to do, take the square root of both sides to get x. But I got to split this now into two pieces. Now we already had on the last one 4, 9, 16, 25. And right off the bat, I'm looking at that 9. And I'm saying, well, I know 9 goes into 72. So I'm going to go ahead and split that off. I want to show you kind of what can happen here. So it's 9 times 8 that gets me 72. Some of you might have thought further and said, hey, 36 has a square root of 6, and I know 36 goes into this twice. 36 times 2 is 72. So this will work. Now both of these will get you to the same answer. It's kind of like when you simplify fractions, and if you divide by 2, a lot of times you're going to have to divide by 2 again, and then again, and again. That's what's going to happen here. If you don't pick the biggest perfect square to fit in, so 36 is the biggest perfect square to fit into 72, this will get you right to your final answer. Square root of 36 is 6. Square root of 2 we can't do anything with. This is going to be our final answer. This will get us there, but it's going to take extra steps because we didn't pick the biggest perfect square. So let's try and finish this one off. So the square root of 9 is 3. And a lot of people would leave their answer like this. The problem is the square root of 8 can be split into something that has another perfect square. So the square root of 8 can be split into square root of 4, square root of 2, and this 3 would kind of just be hanging out here in front still. The square root of 4 is 2, 2 times 2. We can't do anything with this. The 3 is still hanging out here. All of this is being multiplied. 3 times 2 is 6, square root of 2. So you can see I got to the same answer, but it took some extra simplifying. So how do you know when you're done? You always have to take a look at whatever your final radical is and test it and see, can I split it into anything that includes a perfect square? If you can't, then you're done. You're fully simplified, simplest radical form. But if you can, like 8 can split into 4 and 2, then you do need to keep going. The way to avoid this process, again, is to find the largest perfect square that fits into something, and it'll get you right to your final answer. Now, square root of 72, we got to get the approximate answer. 8 point, now we're going to nearest hundredths, so 2 spots. So 48 is going to get bumped up by the 5, and this is going to be 49. So simplified, approximate. Okay, equivalent in the rounded form. All right, last one, number 19. This one can give us some problems just because it's all these variables. So we're going to dig a little deep on this one. If you don't fully grasp number 19, that's okay. This is kind of like a challenge question, but I think it's worth looking at. So we're jumping into Pythagorean Theorem, a squared, b squared, c squared. We have to focus on our c. Here's my 90. So 9 is my c. So x and y are going to go in here. X squared plus y squared. So for this one, we're going to solve for both variables separately. So let's start with x. If I want to solve for x, that means I need to get it by itself. So first thing I'm going to do is expand the 9. So leave this side alone. 9 squared is 81. And if I want to solve for x, that means x has to be by itself. So I'm going to minus y squared from both sides. So it goes away. So now I have isolated the x squared. 81 minus y squared. Can't do anything with that. So I leave it as just 81 minus y squared. And I'm trying to solve for x, not x squared. So I do need to take the square root of this to make it x. But whatever I do to the left side, I got to do to the right side. And so I'm square rooting this entire side over here. And I can't do anything with it. This is as simplified as that answer can be. Can't go any farther. So x is equal to whatever we get when we take the square root of 81 minus y squared. Now we're going to go back and solve for y. So if we can go back to this right here, x squared plus y squared equals 81. If I wanted to solve for y, I got to isolate y. I'm going to minus x squared from both sides now, which leaves me y squared. Can't do anything with this side, so leave it 81 minus x squared. I want y, not y squared, so to get that I have to square root both sides. And I can't do anything with this side. It's going to stay just like this. Now people are going to want to square root these separately, but this is a combined expression. And so we cannot split this up into two separate pieces. The same way we can split up multiplication, right? If we had square root of 9 times 2, we could split that into square root of 9 times the square root of 2. And we like to do that because this would be a 3. Okay, it doesn't work with the addition and subtraction though. So this is our final simplified answer. And again, this is like a challenge question, really going deeper into it. This doesn't quite make sense, nothing to stress out about.